Ready-made maths YouTube training videos. Teacher and teaching assistant mathematics training. This week we are continuing our mastery in place value. We're now up to day 6. Last week we spent the whole week looking at place value for 2-digit, 3-digit and 4-digit numbers, and then slightly beyond that. We're going to be looking for the first few days this week at mastery in place value in decimals. The programme for week 5 and beyond is as follows. Today, day 1 of this week, we're going to be looking at place value part 6, which is decimal place value to 1 decimal place. We'll then move into decimal place value to 2 decimal places, which may take 1 or possibly 2 days. From day 3 or possibly day 4 onwards, what we're then going to be moving into is quite a few days, both this week and in future weeks, on mental multiplication. A lot of people have been in touch regarding the mental addition strategies that we did in weeks 1 and 2. I've been asking whether I could do something similar on multiplication so we can start to develop similar principles for multiplication strategies in kind of year 3 upwards, really, for developing mental multiplication. So later on in this week, once we've finished looking at place value for decimals, we're going to be moving into a whole range of really good, high quality mental arithmetic strategies for multiplication. I won't read them all out so you can see them there. And they will take, a number of days to get through all of those strategies. So I hope you're going to stay with me this week for the decimal place value and then really enjoy the mental multiplication towards the end of the week. Thank you very much.
Hello and welcome to the second week on place value. We won't be taking the whole week on place value, but we're going to be continuing the work that we did last week where we looked at 4-digit, 3-digit, 2-digit numbers, and then we developed that into partitioning in lots of different ways. We also looked at the idea of setting things out as 5 and a bit. We had a very, very practical week last week. We spent the vast majority of the time in the ready-made classroom. We had a little bit of look at a couple of songs and some of the elements on PowerPoint, but mainly last week was looking and visualising and playing with apparatus. Whatever year group we're teaching, if we're working with children and we want them to understand and to master place value, especially at the start of the year, as it provides such kind of clear structure and clear images for all the other topics that children need to cover. It's so important that we start everything off with an actual visual. So welcome back this week, and you'll probably notice by looking at the table that it doesn't look that much different to what it did last week when we're doing 2-digit and 3-digit place value. In fact, it looks very, very much like the 2-digit number activity session that we did. That's obviously very, very deliberate. Part of the key element of decimal place value is that children, again, have a picture. And I think decimals, fractions, decimals, percentages to some extent, but fractions and decimals, certainly, out of all of the different areas in mathematics, in upper key stage 2, tend to cause the most difficulty. A lot of children just see decimals completely in the abstract. It's almost like a decimal number appears and it's, I don't know what to do with decimals, I don't get decimals. And I think the main reason behind that is there's never really that clearer picture of what decimal place value actually looks like. Now, I'm only going to touch upon it, obviously in the sessions that we're doing this week. We'll get, a chance to have a look at some simple visuals for decimals. But even if we just take those and start off the whole process with a look at some examples of decimal place value, it immediately builds on what the children have done before in Key Stage 1, and then allows them to develop their decimal understanding in Key Stage 2. So that's what we're going to be doing over the course of this session. Now, something that I used a couple of weeks ago when we did the early years training was a look at tens frames and how they could be used. Now, these are the tens frames I often use in year 1 and above, just allowing the children a kind of a quick visual glance. I'll hold up a tens frame and ask the children, what can you see? And obviously, as a Key Stage 1 activity, there's many, many answers. What do you see there? Let's just keep it in Key Stage 1 for the time being, and let's just have a look at that picture. If I kind of showed you that picture and just left it there to look at, what do you see and how do you see it? Hopefully you'll see the number 7. How do you see the number 7? And it's quite interesting when you've got a consistent picture, and we looked at loads of those in the early years work in looking at tens frames. If you've got a consistent picture of 5 at the top and 2 at the bottom, most children see it the same way. But with this one, what do you see? Well, I see 4 at the top, 2 here and 1 over here. Or I see 4 and 3. Or I see an 8 with 1 missing. Or I see a 4 over there and a 3 over there, as if it's a couple of Numicon pieces. Overall though, there's 7. Let's think of that now from a fractions point of view. What fraction of that box is full? Now again, this is the sort of work that you need to do to prepare the children for decimal place value. They need to have first met it as a fraction. Now there's work coming up on fractions in future weeks, and we will be touching certainly upon this idea. But children first of all need to look at that and go, well, there's 7 there, but there's 3 that are missing. It's a tens frame, I've got 7 out of 10, therefore that box is 7/10 full. Once we've got that established, that's going to really help us with the decimals. If I choose a different one, let's look at that one. You know, what does that look like? We won't pause the camera this time, but hopefully, because there's 1 missing, I'm looking at that and going, well, that box has got 9 in, if I'm in year 1. I know it's got 9 in, because it's got 1 less than 10. I can also see that it's 9, because there's 5, which is the top half, that's half a box, 5 out of 10. Even think of that language, 5 out of 10. I've got 3 there, which gives me 8, and 1 there, which gives me 9. Or I've got a Numicon 6 or a dice 6, and I've got a 3 over here. I've got 9. What fraction is full? 9 out of 10, 9/10. What fraction is full? 8 out of 10, double 4, 4 2s. 8 out of 10, 8/10. It doesn't really matter what the number is. I can get some smaller numbers from later in the pack. Just something as simple as that. That is a conventional one. That's got 2. In early years, there's 2 there. Both of the 2 are on the top. It's 2 out of 10. It's 2/10. So that's the starting point for today's decimal work. I want to make sure that the children have spent quite a while in their fractions activities really looking, as well as at quarters and halves and thirds and sevenths and eighths, that they've really secured the idea of tenths as well. And if we're talking about children in years 4, 5 and 6, there has to be that link between what they discover in tenths as a fraction activity and what they're then going to do with decimals as a decimal activity. It's the same picture, it's the same number, we're just reading it in a different way. So as I'm looking at, for example, if I'm looking at this picture here, in early years, year 1, that's the number 3. By year 3 really to 4, that's 3 out of 10, or year 3 really, that's 3 out of 10, 3/10. Then it's going to become, eventually, 0.3. And let's have a look now at how we get towards that point. It always feels quite interesting doing a session on decimals and holding up a tens frame and linking it back to the work that I did on tens frame in early years and the work that I did on place value with year 1 last week. In the early years, year 1 sessions, we talked about this being 10, 10 ones, 1 10, 10 ones, 1 10, 10 ones. So the children get used to holding up a 10 and knowing that in that box it's full, therefore it's a 10. And when I bring it down, I can see that it's made up of 10 ones. I do exactly the same with decimals when I want children to realise the decimal value of this box. As a fraction activity, what have I got? I've got 1 whole box, which is 10/10. I've got 1 whole box, which is 10/10. Got to start off like, there are definitely 10/10 there. This is the same image that was used in Key Stage 1 for understanding 10 and tens. It's now the same image I'm going to be using for decimals in Key Stage 2. It's definitely full, it's definitely a whole box, there's definitely 10 in it, so it's 1 whole and 10/10. We're not going to write that as a decimal yet. This is the fractional understanding first. We know that 10/10 make a whole. We've also learned that 8/8 and 4 quarters and 3/3 make a whole, but we are now focusing specifically on the tenths. 10/10, 1 whole is 10/10. How does that develop? Well, if I introduce an additional whole, it's worth just kind of posing the question now. When I hold them up there, how many whole boxes are there? You can see that both boxes are full. So we're going to pause the video in a second. How many whole boxes and how many tenths? How many whole boxes and how many tenths? So what have we got? Well, hopefully you can see the number of whole boxes is 1, 2. So we still have 2 whole boxes. Used to be 2 tens, it's now 2 whole boxes. How many tenths? 20 tenths. Let's see that connection between kind of that year 1 idea of 2 tens, 21s, 2 tens, 21s, and the fraction decimal idea of 2 wholes, 20 tenths. 2 wholes, 20 tenths, with the idea being that this is 1 full box. As we introduce a third box, okay, we've got a third one here. We can see 1, 2, 3. I won't hold them up this time. I can't hold all 3 boxes up together, but if I just look at them, we've got 1 whole, 2 wholes, 3 whole boxes that are full. 3 whole boxes that are full. How many tenths? 10, 20, 30, 30 tenths. We know it's 30. We've been doing it as 30 ever since Key Stage 1. We know that that's worth 30, but it's now worth 30 tenths, with that being my whole, that being my second whole or my second full box, and that being my third. Let's just develop that now by looking at some boxes that I've got over here that aren't full. And this is where we start to really move into the decimal idea. At the moment, in a way, we're definitely still in the fraction idea. We've got the wholes and the tenths. Let's just bring a very obvious one into play. This is a lovely one to explore with year 3 when they're doing fractions work to begin with. Let's have a quick look at what we can see there. What can we see? How much is full? Well, early years, year 1, what can we see? We can see 5. We know it's 5, it's a half of the box. 5 is a half of 10, just like on my fingers. We're now looking at fractions in year 3. What do we see? Well, we see 5 out of 10. Interestingly though, 5 out of 10 is still 1/2. So we're getting an idea of 5 tenths being a half. So what can we see now? We can see 5 out of 10, 5 tenths, 5 tenths full. We're still dealing with fractions. How do we turn that into a decimal? Well, what we do is we go back to the number of whole boxes. And this is the first change as we kind of develop from a fractional idea of 5 out of 10, 5 tenths, into a decimal idea. First of all, if I hold it up there, how many full boxes have I got now? Well, none. I have not got any full boxes because the box isn't full. So I've actually got no full boxes. What have I then got? 5 tenths. So no wholes and 5 tenths. No wholes and 5 tenths. We're going to look very, very shortly at how that transfers over to a decimal. I'm going to show you one more and then we'll go over to the place value board. What have I got here? Again, what have I got first of all as a number of counters in a box? Well, I've got my 5 and a bit that I've spent so much time emphasising over the last few weeks. 5 and 3, 8. There's also 2 less than 10, which makes 8. I've got 8 out of 10. I've got 8 tenths. The box is 8 tenths full. You can probably see how much language I'm using here over and over again, that repetition idea. And if I'm doing this in class, I'm constantly asking the children, so what do you see? How many whole boxes? None. How many tenths? 8. What can you see? 8 tenths. That's all the fraction idea, and then that's going to transfer over very shortly into the idea of a decimal. There's no whole boxes, I'm 8 tenths. No whole boxes, I'm 8 tenths. That's what we can see at the moment. How many tenths do we need to fill the box? If we want to do a little bit extra, I can see, if I want to look at this now, I've got addition of fractions there. 8 tenths and 2 tenths, that makes 10 tenths or 1 whole. But that's for a different day. We're looking now just at the visual fraction of 8 tenths. So we've looked at 1 whole, 2 wholes, 3 wholes, we've looked at 5 tenths or a half, and we've looked at 8 tenths or a half plus 3 tenths, if you want to see it that way. What we now need to think about is how does all that work that needs doing, in the previous block of, in the previous unit on fractions, how does that transfer over to actually representing it now as a decimal? So let's stop there. I'm going to take you over to the ready-made maths number board. What I've done now is done a kind of alternate version of what we looked at last week. Last week we were looking at thousands, hundreds, tens and ones. I always prefer to write my place value columns with numerals. I think that idea, the idea of the etc., as we always used to do, it's fine, but as I said, this is not a literacy activity, it's a mathematics activity, and I think it's far better if the children are looking at the place value columns and seeing what they're actually looking at. So last week we looked at, if we were looking at the number, 3,261, we'd have 3,000s, 200s, 6 tens and a 1, 32 hundreds and 61 ones and 362 tens. We looked at all of that last week. If you didn't get the opportunity to look at the greater depth of place value, please have a look at day 1 and day 2 in last week's videos, where we really looked at thousands, 4-digit numbers. But what we're doing now is we're extending the place value columns this way. And again, that old-fashioned T, H, and that, where what we do now is we put it in lowercase to represent tens, hundreds, and thousands. Why not represent tens, hundreds, and thousands with tenth, hundredth, thousand? If you want to put the S on the end, that's absolutely fine. We're looking at the number of tenths, the number of hundreds, and the number of thousands. That's what we're going to be developing as we're doing place value. So I've started off with a relatively straightforward one. We've started off, let's actually start with the third one. Let's start with the third one, which was this particular picture that we looked at. We've got to start in the concrete. We don't start up here and say, what's 0.5? That's beginning with the abstract and going backwards. We need to start that CPA approach from the Far East
has now been kind of taken into mastery in the UK. The idea of, let's have a look at this and let's go concrete first of all. We can see 5/10. How do we write that? Well, how many whole boxes have we got first of all? We've got no whole boxes. We have got no whole boxes. How many tenths have we got? 5. And that to me is how we move from basically the concrete via pictures as well towards the abstract. What can you see here? I can see no whole boxes, so I certainly don't have any ones. I don't have any full boxes, but I've got 5/10. I've got 0.5. Similarly, how do I write this one? Let's make it the right number to begin with. It would be helpful. How do I write this one? What have I got there? Again, I've got 7 out of 10. I've got 7/10. But what I definitely don't have is a full box. I have no full boxes whatsoever, but I've got 7/10. So I can see there, I've got no holes, but 7/10. And now I'm seeing actually that's another way of writing it. This is how I write it as a decimal. I write it as 0.7. But 0.7 is the same as 7/10. So I can see 7/10, I can see 0.7. I can even see 5/10 and 2/10, or 0.5 and 0.2. And there's 3/10 that I need in order to fill the box. So there's always this constant link between the fractions and decimals as well. So we're always establishing that 0.7 has a value of 7/10. Again, often that's done kind of separate. Fractions is learnt, decimals is learnt, and they kind of come together. But let's make these links all the time. 0.7, 7/10, 0.7, 7/10. No holes and 7/10. 0.5, 5/10. No holes and 5/10, and so on. That then brings me to my full box. So I have my whole box now. What have I got now? And this is where we've got to look at the place value chart and try and think, right, what can I see here? Well, I can see one whole box. And I know that one whole box is 10/10. Now, although as a decimal, we would not normally write 1.0. If we're actually looking at how many tenths, that's what we can actually see. We can write it as 1.0. It's worth exactly the same. If someone was to say how many tenths in a hole, well, we know 10/10 are in a hole, and we can see 10/10 are in a hole. One hole is equivalent to 10/10. We don't usually write, normally, conventionally, we don't usually write the 0 unless we have any hundredths. But at the moment, we can definitely write it either of two ways. We can write it as one whole, which is just written as a 1, or 1.0, that just tells us how many tenths. I've done it in a different colour, just to show that. As we then move on to 3, we've now got, well, I'll try and leave them down there. We've got 1, 2, 3. I've got 3 holes, and I've got 10, 20, 30 tenths. Let's move back to the board over here. I can write it down. How many holes have I got? 3. How many tenths have I got? 30. And that's how many tenths I've got. I've got 30 tenths. I've got 3 holes. I've got 30 tenths. Obviously, we tell the children, we explain to the children that conventionally with decimals, until we have a number of tenths, or until we have a number of hundredths as well, conventionally we just write 3. Of course we would, because it's 3 full boxes. But if we want to know how many tenths, that's worth the same. We've got 30 tenths, which is worth 3 holes. Now, what we're going to do now is going to move it on very, very briefly to these 2 numbers here, which I've not actually looked at yet. So we're going to go back to the table. We're going to look at the number 1.8. We're going to look at the number 2.4. We're going to look at what they're worth, and then we're going to think about how that transfers over to the place value chart. So we'll start off with 1.8. And there we have, well, have we got 1.8? How do I know that's 1.8? I'm just telling you. Have a look at that. If I was to say that is 1.8, I'm going to ask you now why. Let's just pause on there and have a think. So here is, as I've told you, at 1.8. Why? Let's have a look first of all. Why is this 1.8? Well, first of all, how many tenths have I got? Well, I've got 10 tenths there, and I've got 8 tenths here. I've actually got, altogether, 18 tenths. As long as I know that that is my whole, that's my whole, that's my 1. 1 whole is 10 tenths. I can now see this is worth 18 tenths. Have I got 2 holes? No, I've only got 1 hole. This one's not full yet. It's nearly full. It's 2 tenths away from being full, but at the moment, it's not a full box. I've got 10 tenths and 8 tenths, 18 tenths. I've got 1 hole and 8 tenths. I think you can also see what other object is being covered here in fractions. This is an absolutely brilliant improper fractions to mixed numbers activity. So again, when children are trying to secure that understanding in an earlier block, we can see here 18 tenths, 1 and 8 tenths.
18 tenths, 1 and 8 tenths. When we cover fractions in some of the later videos, again, we'll emphasise that point in a lot more detail. Let's take that idea now of 1 and 8 tenths, 18 tenths, 1 and 8 tenths, 18 tenths, over to the board, and let's just see how it looks. So we had 1 whole and 8 tenths. We had 1 whole and 8 tenths. That gave us 18 tenths. 1 whole and 8 tenths, 18 tenths. Or, as we're now calling it, 1.8. The point, the decimal point, is basically kind of separating our wholes from our tenths, hundreds and thousands, or the fractions that we're going to get, the decimal fractions that we're going to see. Rather than picking up and moving the tens frames or the egg boxes now, I'd just like you to have a look at what you can see in front of you. Thinking now back to the place value chart and taking on board, this will take obviously quite a while to do with children, and it will all be done practically first. I want you to have a look at that picture and discuss what can you see as wholes and tenths, what can you see all together as tenths, and what would that be as a decimal. So 3 things. What's the whole and tenths? So how many wholes, how many tenths all together, and how would you then write that as a decimal? So let's have a see. There's 1 whole, there's 2 wholes, and there's 4 tenths. I've definitely got 2 whole boxes and 4 tenths in a box. I've got 10, 24 tenths. I've got, just use that as a decimal point for the time being, I've got 2.4. So I've got 2 wholes and 4 tenths, or 24 tenths, or 2 and 4 tenths, 24 tenths, 2.4. Let's go back to the board, and that's what we can see there. Let's just check. We can see we had 2 whole boxes, we had 4 tenths in a box. Altogether, because there's 10 tenths in one box, 20 tenths in 2 boxes, 24 tenths in 2.4 boxes. And it's written as 2.4. 2.4, 2 wholes and 4 tenths, 24 tenths, 2.4. We've backed all that up with the visual stuff earlier on. We've transferred this over here later in the week. We've made sure the children have had lots and lots of practice of talking. The most important thing, as well as the visual, is the language. We've got to get children used to saying wholes and tenths, tenths, wholes and tenths, tenths. Doing all of that with the fractions work, so by the time we start to look at decimals and we start to give it more of a consistent structure and we start to link it into our place value system, it's already something that's in here, it's already something that's been practiced with fractions, and therefore it's something that hopefully will transfer it over much easier. Another resource that we could use, which can be a lot quicker than getting the egg boxes all of the time, is Numicon. Numicon can actually be used in the same way as the egg boxes. This Numicon piece here, I've just filled a 10 piece with stacking counters. What's quite nice about stacking counters is they do fit beautifully into the Numicon piece. I've just randomly gone for 10 counters. I didn't colour code it this time. 10 counters in, but it's full. I've got a full box of 10. So what I could do, if I don't have egg boxes available, if I do have stacking counters and Numicon, I could actually do the same activity with those as well. 10 tenths, 1 whole. But hopefully we can see 10 tenths is 1 whole initially by looking at the actual spaces on the Numicon piece. So if I'm saying this is my whole, this is worth 10 tenths. I'm going to put that down there on the desk now, and let's have a look. What can we see? It's just obviously a quicker way of doing the same thing. I would definitely start with the egg boxes because it's physical and it's practical, but I'd say, right, there's my whole, and that used to be worth 3. It's now worth, as we can see, if I put it there, it will be worth 3 out of 10. So what I can see there is 1 whole and 3 tenths. I can see 13, which has always been the number 13. It's now 13 tenths, or it's 1.3. Again, I'll just bring my stacking counter over here to represent the decimal points. So I've got 1 whole and 3 tenths, 13 tenths, or 1.3. What do I have over here? Well, over here, I'm almost at 3. I'm almost at 3 wholes, but not quite. I've got 2 wholes and 8 tenths. I've got 28, as I always had. This was always the number 28, but it still is the number 28, but it's now 28 tenths, or 2.8. Let's look at that again. 2 wholes and 8 tenths, 28 tenths, 2.8. If I was to add another 0.2 or another 2 tenths, I will then be at 3. And it doesn't really matter how big the number gets. I get to this point, what have I got here? I've got 3 whole boxes, or I've got 3 holes, if this represents my hole. I've got 3 holes and 7 tenths. I've got 37 tenths. I've got 3.7. And remembering that 5 and a bit structure that we've been using all of the time, if you watched any of last week's videos, in particularly Thursday's video where we looked at 5 and a bit, if I was to now set that out, I might as well leave the 0.7 there. I've now got, rather than putting them in a straight line, I use that 5 and a bit idea. I've now got 6 holes and 7 tenths. So 6 holes and 7 tenths. I've got 67 tenths, or I've got 6.7. The 67 tenths actually could be done like that. So there's my 6 holes and 7 tenths, 67 tenths, or 6.7. It's a great way to use Numicon, and it proves that Numicon is not just a Key Stage 1 resource. There's a lot of value in it. There's loads of uses for fractions, but it can also be used really effectively for decimals as well.
As you can see, this is really what we've been looking at today. Lots of different images that all show that idea of decimal place value. Now, what we can see here is a standard arrow card image that we didn't really look at today. 7.4 is 7 holes and 0.4, as it is here. We would normally see that 0.4 is 4 tenths. We've then got the image here, or the egg box image. We've looked at that today with slightly smaller numbers. Well, what can we actually see from this image? As we've just been looking, we can see 5 whole egg boxes here, and the 2 whole egg boxes, again, in that 5 and a bit arrangement, that gives us 7 whole egg boxes and 4 tenths. What we can also see is the number of tenths altogether, which is 74. 74 tenths, 7 holes and 4 tenths, or 7.4. We can see the number line image up here from 0 to 10. So 7.4 is about 3/4 of the way down. But for 7 to 8, it's not quite halfway. And that's something we've not looked at in this particular training. There's also some high quality place value work. And then we're going to move on to this tomorrow, looking at actually the whole as being the 100 square. So the 100 square, rather than representing 100, is now representing 1 whole. We'll be looking at that tomorrow as we go into a decimal place value to 2 decimal places. But as a kind of a glance before we look at it, we can see straight away 7 holes and 4 tenths. We can also see it with place value counters as well. So we'll be looking at that in tomorrow's session.
I'm going to conclude this particular part of the training by kind of doing a decimal version of an activity I did last week on a much larger scale for thousands, hundreds, tens and ones. I actually poured on the table absolutely loads and loads and loads of ones, and it turned out to be something like 1,215 or 1,235. We had 1,235 ones, and we exchanged them into tens. Then we exchanged them into hundreds, and then we took that into thousands. I want us to do the same thing now with decimals. And just look at what we've got here. I'll just pour it on the table. I have no idea how many there are. I just basically emptied a load of cubes onto the table. Now again, we've got to establish before we do the activity that those cubes are not worth 1 each, they are worth 1/10. And that basically the box is the whole. What I'm going to ask the children to do first of all is to estimate how many boxes do you think you would fill with those. Now I don't know, I'm looking at them and thinking probably about 5, it might be 6, possibly 7, but I'm thinking it might be 5 or 6. I don't know until I actually do the activity. I'm not going to do it as a colour-coded activity. I'm just going to ask, again, I would ask the children to do this, and I'd probably pour a load of cubes on each table and put a load of egg boxes on each table and say, right, we're going to explore now from the word go. This is how many tenths we've got. How many tenths do you think there are there? Once the children have made that estimate, then the activity is basically work together, fill the egg boxes, and let's see how many tenths we have and what that's really worth. So we're going to kind of just go into a speedy version of this activity, and we'll just see how long this takes to do. With that activity finished, what can we see on the table? Well, what we can see is 1, 2, 3, 4, 5 whole boxes. We started off with lots of tenths. We've now got 5 whole boxes and 7 tenths. What did we actually start off with? We started off with 57 tenths. So its basic value was 57 tenths. We've now put them together and we can now see that it's 5 holes and 7 tenths as a decimal. We move over to here. I could have just gotten rid of the thousands, but I could have initially just leaving the thousands and the hundreds out of the way for a minute. Just starting with the 10. I could have initially said that, well, what I've got there is 57 tenths, which is what I actually had. 57 tenths as a fractions activity, which is 5 wholes and 7 tenths. We've got that proof that we've just looked at on the desk. There was 57 altogether. We put them into 5 boxes. That was our 5 wholes, and we had 7 tenths left over. So brilliant improper fractions mixed numbers. Now as a decimal, we had 5 wholes, or 5 full boxes, and we had 7 tenths. So 5 wholes and 7 tenths, 57 tenths. Thank you so much for watching today. I hope you found the activities useful. We haven't really used many pieces of apparatus today. We've really only used multi-link cubes, egg boxes and Numicon. But to be honest, that's how I always start in class. I don't want to make it too complicated. I don't want to bring out lots of different resources. And more importantly, I want to link what they've done in fractions to what they're going to do in decimals. I want to build on what they've already done before. I want the fractions work to build on what they've done in Key Stage 1 with 2-digit numbers. And that is a key part of mastery, that the images that have been used further down the school are then used again and transposed so they have a slightly different meaning. So if we did have, in Key Stage 1, as we've said before, 18, we've still got 18. That hasn't changed. What has changed is what the 18 is now worth. Before it was worth a 10 and an 8, now it's worth 1 whole and 8 tenths. It's still 18, but it's now 18 tenths. And that's basically how we can develop that mathematical understanding so that nothing's new. It's just a slightly different variation on what the children have done before, which is a really, key element of the mastery curriculum. Please join me for the next session where we're going to be looking at decimal place value to 2 decimal places.
Thank you very much, and I look forward to seeing you tomorrow when we look at decimal place value for 2 decimal places. As you've seen today, the main focus has been CPA. It's concrete to pictorial to abstract. We don't kick off with abstract numbers on a board and then try to explain them. We start with the picture, we start with the image, we start with the visual, we take that visual, we build up the children's visual understanding so they're starting to master what it all actually means, and then we start to go towards the board and give it a kind of abstract written version of what the children already know. So tomorrow, as I've mentioned, it's decimal place value, but this time to 2 decimal places. We're going to take base 10 and we're going to represent it in a slightly different way. So it's a familiar image, but we're going to be using it slightly differently. Look forward to seeing you all tomorrow for decimal place value to 2 decimal places. Thanks a lot, and I shall see you.